All right, so what I'm going to do here is sort of a quick intro to diagnostics with ion. There's a whole bunch more that hides behind this, but this will give you at least a couple of hints as to where to start looking if things aren't doing what you expect. And this sort of gets into what are the kinds of things that if you call for help, the kinds of things that we'll need to look at in order to sort of get started diagnosing things. So uh, we'll go talk about the ion.log file, which you talked about a little bit before. I'll talk a little bit more about watch characters, and after I go through the slides, we'll load up one of the scenarios and turn on the watch characters and actually see those in action. So we'll get a chance to watch that work. And then a couple of some of the diagnostic commands that you can run within the ion suite are things like BPStats, which we've done before, which dumps the statistics into the ion.log file, and this thing SDR watch that will look at the ion SDR and tell us things about that. And if there are cases where you think things are running out of memory or running out of resources, SDR watch is sort of a place to go look. If bundles aren't moving the way you think they should, sometimes BPStats can be helpful there, just to see if a node actually thinks that it's transmitting when you think that it's transmitting. Ion.log file is generated generally in the directory where from which you have started ion admin. And again, here's sort of all these little I's in brackets are informational. So this is just telling us things, ion, the RFX clock, the sort of the basic clocking mechanism is started. Ion warn is looking for congestion issues. We've gone through, we started an IP, apparently when I built this slide, I started an empty ion sec admin. And this is talking a little bit about, this one has got some information from LTP. So here's a span to engine number 2, talking about that, and some of the both the LTP link service input and output, as well as there should be here's the LTP CLO, the IPN scheme forwarder, and looks like another LTP CLO. So all of this stuff that's above where the highlighted lines are is standard, and then this is I think Ion will also dump out the stats. Actually, I don't think it dumps the stats when you start. So if you do a BP stats, you'll get this stuff that's highlighted, and what this is telling us is bundles that have been sourced between, and this is sort of the beginning of the epoch back in 1969 up until when I ran the command, which was sometime in April. So these are bundles that have been sourced by a node, so things that were generated by either the administrative endpoint on the node or an application, things that have been forwarded by the node, things that have actually been transmitted. So that's really important when you're diagnosing problems with routing where bundles aren't going out. You can look to see if it really thinks it's transmitting or not. And so if you think that bundles should be moving and that transmit number is 0, then that's probably a problem. Received, delivered, custody transferred, re-forwarded, having things that had to be retransmitted, and then finally expired is also really important. If you're seeing lots of loss that you can't explain, looking on the expired line might be useful. So these are counts for the various priorities, so bulk, normal, and expedited. And then there are 2 numbers in there. There's a bundle count and then a byte count. And then the plus that's over to the right sort of is the sum of across all the priorities. Again, if you run BPStats, the BPStats command from the command line, it simply returns, but it does cause Ion dump a new set of statistics into the ion.log file. So here you'll notice that the start time hasn't changed. That's still back in 1969, but now we've got some bundles. So we apparently at this point had sourced 13 bundles of priority 0 and 1 bundle of priority 1. So a total of 14 bundles, and you can walk down this list. Talked a little bit before about watch characters. Ion will, if you configure it to, Ion will spit out some single character mnemonics when various events occur. And those can be useful to figure out sort of where, again, what Ion thinks is going on. Are bundles being received? Are they being queued for transmission? Are they getting stuck somewhere in LTP? And the place to find those is the terminal that caused the watch characters to be generated. And so for us, all that stuff gets started by all the Ion admin programs are run by a particular script, and that's the core ion config.sh file, and it redirects its output into core ion config.out. So all of the watch characters are going to get dumped into core ion config.out. And we can watch that happen. And then there's there's an extra little tool that's a graphical tool. If you SSH into the node, and I'll talk about how to do that, you can cause it to dump that information in a big scrollable list that also time tags them, which can be useful if you're trying to figure out some timing issues. You can watch sort of when things happened. Otherwise, you get a stream of watch characters, and you don't really have a good idea of when those events occurred, just sort of what happened and the order in which they happened. So here's an example of what you might see. This is just calling tail -f on core ion config.out. So this is information that got dumped out by the various admin programs when things started. And then down here are all of the watch, oops, move that around. Down here are all the watch characters. So, B, C, D, E, F, G. Generally, the general way to interpret the watch characters is normal ASCII, A to Z letters tend to be normal functioning of the protocol. And if you see anything in there that's a punctuation character, those tend to be things where something has gone wrong. Here's a version of a watch character decoding ring. So this has got the watch characters for bundle protocol and LTP. So you can just sort of read through these. In general, though, A's and B's are generating things. Y's and Z's are bundles arriving at a destination application and getting queued for delivery. And then there are a whole bunch of sort of error codes that for various things that can go wrong. And similarly in LTP, you've got D and E are segments that are getting created and queued for transmission. S and T are segments that are segments being received and a block being fully received, and then various other error codes for when things go wrong. So what did the first few characters, if we go back up here and look at what was coming out, we got B, C, D, E, F, G, S, H. What does that mean? So B is a bundle protocol watch character, bundle queued for transmission, bundle pop from its transmission queue, so that's actually going out. Bundle appended to a block for the next session. So this is going into LTP. If you remember earlier when we talked about LTP, I said that there are some parameters in the LTP configuration that allow you to aggregate multiple small bundles into a single LTP block. So this is that bundle being appended to that block, and then E is segments, that block then gets segmented by LTP when it's time to go out, and various segments of that block are themselves queued for transmission. Apparently this was really short because the block then had been fully segmented. We popped a segment off the transmission queue, we received something, and it turns out that reception was a positive ACK for the block. So that was an entire bundle going out in a single LTP segment, so it was probably a ping or something else that was very short. And then we've got another, we popped another segment from the transmission queue, we sent something else, and sent a couple of other segments for LTP. At this point, we had fully received a block coming in the other direction. Probably the LT, I suspect maybe the ping response. We accepted a bundle, so that's good. And finally popped the LTP segment. Another LTP segment went out for something else.